Hello students, welcome to the next lecture of the ordinary differential equation. In the previous lecture we had started solving the equations which can be reducible to homogeneous differential equation. We had discussed the case 1 in the previous lecture. In this lecture we will discuss case 2. So if you remember in the type of the homogeneous differential equation, so the case 2 can be recognized by seeing this ratio whenever a upon a is equal to b upon b, just opposite to the previous case 1 where it is not equal. So in this case, if a upon a is equal to b upon b, then this will the second case will be applied. So let's see what we'll do when the second case applies. In that case, we will take this equal to 1 upon m, where m is any constant. So we'll take a upon a is equal to b upon b is equal to 1 upon m. So from from first and the third equation, the capital A will be equal to small a m, and from second and from third equation, the capital B will be equal to small b m. So we will replace these capital A and capital B into the original equation. So the original equation will be like this. So dy by dx is equal to ax plus by plus c. Numerator will remain same. The denominator will change. So we'll take m as common once we'll replace capital A by am and capital B by bm. So this will be replaced, and the denominator will become m ax plus by plus c. Now you can see in the numerator this term ax plus by, and in denominator this term ax plus by is same. So now what we'll be doing is we'll put this ax plus by is equal to some another variable that is equal to z. So this ax plus by will be replaced by z. So this will become z plus c in numerator, and in denominator this ax plus by will be replaced by z. So this will become mz plus c. And obviously we'll have to replace this dy by dx by dz by dx. So we will see this replacement can be obtained just by differentiating this substitution. So let's see an example on this type 2. So this is the example on the type 2. So the equation is given as dy by dx is equal to minus 2x minus y minus 1 divided by 4x plus 2y minus 1. So we can see here small a is minus 2, capital A is 4, small b is minus 1, capital B is plus 2. So we will taking the ratio and we'll see that the ratio is equal. So in that case, we'll use this numerator part ax plus by and this 2x plus y. We will substitute this with another variable that is z. So with this substitution, we'll differentiate this equation. So with respect to x, so now this will become 2, and this is dy by dx, and this will become dz by dx. From this, we can see that dy by dx comes to be dz upon dx minus of 1. So we have to replace 1, 2x plus y is equal to z, and second dy by dz is equal to dz by dx minus of 1 in the original equation. So on replacing, we get this equation. You can see on the place of dy by dx we replace dz by dx minus 1, and in the original equation replacing this 2x plus y by z we got minus z minus 1, and in the denominator 2z minus 1. Now we can convert this easily into variable separable form. So this is the objective of our substitution, to convert this into variable separable form. So now you can see that this is converted into variable separable form. So this is integral of dx and integral of 2z minus 1 upon z minus 2 dz. So now we'll simply solve it using the concept of the variable separable. So you can see that this integral can be divided into two separate integrals, 2z upon z minus 2 with dz and 1 upon z minus 2 with dz. So this can easily be solved with the help of substituting z minus 2 as t, so we need to substitute z minus 2 as t, so dz will be substituted by dt. So now just by these two substitutions, again the equation, so you can see this is the equation. The 2z and z minus 2 will be replaced by t plus 2 in the denominator and t plus 2 in the numerator and t in the denominator, and on the right hand side this log of z minus 2 can be easily considered as log of t. So we have performed the integration of this 1 upon t. 1 upon t is, we know, log of t, and here we'll again we will different we'll separate this integral into two integrals. One is t upon 2, another is 2 upon t. So again on integrating we get 2t from the first part and 2 of log t from the second part, and this is minus of log t coming from this third part. So just performing the simple integration and then substituting back the values of t. So we had taken t as z minus 2, so we will substitute this. So here it is 2z minus 2 log of z minus 2, and the third part will be again in the log. So we have and finally we'll substitute the z. So we, if you remember in the beginning we had substituted 2x plus y as z, so we'll substitute that z back into our equation. So this will be our final solution of the ordinary differential equation. Let us see one more question based on the same type 2. So we can see this is another question here it is given. So the first thing is to identify the ratio. Small a upon a is equal to small b upon b. In this case, yes, this is equal. So we can see that type 2 will be applied, and in that case we'll need to substitute these two values. 3x minus 2y is equal to z, and dy by dz is equal to dz upon dx plus 3 upon 2. We can obtain this just by differentiating the above equation, this, the substitution. So just by replacing these two substitutions, we can see that the equation can be easily converted into variable separable format. So now we can see that this is dz upon dx is equal to 4z plus 3 upon 2z plus 1. This is variable separable form. Now we can solve it just by performing the direct integration, and for that we'll use the substitution. So the substitution here we'll be using is we'll taking z plus 1 is equal to t. So this z plus 1 will be replaced by t, and the integration will be performed. So now finally we can see that this will come after integration, t minus log t plus 3 log of 3z plus 1. Now we'll replace the value of t back into the equation. So this is z plus 1, this is again z plus 1. So now we'll replace the values back, and now finally we'll replace the values of z back into the equation. So we'll have in place of this z we'll have 3x minus 2y plus 1. Similarly here also. So now this is the final solution of the question. So in this way we can solve the homogeneous equations, non-homogeneous equations that can be reduced to homogeneous equation, which follow case 2, by converting them into the variable separable form. So that's it for the lecture. Thank you so much.